Our next speaker, John Pollack, has been with Microsoft for over 5 years, and in that time he's worked on virtually every product developed by System Software. As a member of the product support team for Windows, he's processed countless requests for technical assistance from independent and corporate software developers, so he has a great understanding of your Windows application development problems and how to solve them. He is currently putting that knowledge to special use as a senior teacher for Microsoft University, where he conducts advanced courses on Windows and on the Presentation Manager for OS2. In this talk, he'll be discussing the programming model to use in developing your application with Presentation Manager.
In OS2, the basic unit of I/O management is the screen group. The screen group is the virtualization of the system console device. It is a virtualization of the mouse, keyboard, and the screen. On the screen now is my representation of multiple screen groups. On your left is a rectangle that says Screen Group 1. What that is meant to indicate is that that screen group is a virtualization of the console. And it's used to represent that at any one time, either Screen Group 1, 2, or 3 will be active. And that screen group will be getting mouse input and keyboard input, or will be receiving output from the programs. Each rectangle is mutually exclusive, and only one rectangle is active at any one time. So one should look at this as if Screen Group 1, 2, and 3 were each overlays on the console device, on the display console that you're using, the screen that you're using. On the screen now is the same picture as before, but Screen Group 1 is labeled Presentation Manager. In OS2 and the programming model for OS2, the first screen group in the system is the Presentation Manager screen group, and the Presentation Manager takes over one virtualization of the console and treats it as its own. Windowing is the means by which input and output of the Presentation Manager to a screen group is multiplexed. So the Presentation Manager takes control of one virtualization of the screen, that's Screen Group 1, and it then partitions that screen group into smaller pieces. Okay, and that's what I mean by multiplexing. So windowing is the means by which we take a single screen group and we break it up into multiple smaller pieces of real estate. So you can think of a window in the Presentation Manager system and in the Presentation Manager programming model as a sub-console or a sub-screen of the Presentation Manager screen group. On the screen now is a rounded rectangle which is meant to represent the console, and on that console are a number of overlapping rectangles. These are the windows. So in a very direct way, what we want to get across is the console is one virtualization of the keyboard, mouse, and graphics output. And the way that one virtualization is partitioned into smaller pieces is by creating windows. When you have a mechanism like this to take a single piece of screen real estate or one virtualization of the screen and break it into smaller pieces, you have to come up with some means of directing input and output to the smaller pieces. And messaging is the mechanism we chose to do that. And we enforce input serialization, that input should be serialized, and output synchronization, that things have to be painted in a specific order, by using messaging. Okay, so message processing is the chosen means to achieve serialization and synchronization. To your left on the screen is the Presentation Manager screen group and a window. Below it is a dashed outline that is meant to indicate a process or a program running in the system. Inside of that process is a thread of control, that is the bent arrow or the circular arrow, and that is processing messages from a queue. The dotted line to the process and then to what you see on the screen is WinProc indicates the flow of information from the screen group to the process, from the process to a window proc. So this is the Presentation Manager schematic for information flow in the system. This is the overall picture. Now we'll take this overall picture and we'll go through it one part at a time and explain what is happening, because this is the schematic model for all input and output in the Presentation Manager. In the beginning, and on your screen now, is the master screen group. A screen group is created, and into that screen group are launched processes. So each process in the Presentation Manager is launched into the Presentation Manager screen group. So there's a screen group first, and then each process shares its I/O with the screen group. On the screen now is the screen group and a process, which is a set of resources, and into the process is placed a thread of control, or a program counter, if you will. And that is what is meant by the circular arrow. The process consists of the screen group in which it's running, the file handles that the program has, the LDT tables or the memory tables, and a control thread. So we start with the screen first, and into the screen we start a process, and that process contains files, memory, and a control thread. Okay. On the screen now is the same picture as previous, but with an addition of WinProc, as you see. Okay. An application which wishes to create a window registers a procedure to perform input and output. To perform output and to accept input for the window. This is called the window proc, and it's synonymous with the Windows class. So in the Presentation Manager, when you wish to create a window, you register a procedure to process input and output for the window. That is what we call the WinProc, and it's synonymous with the class of a window. So the procedure that is to do input and output is the class. So you register that. Okay. If once you've registered a window, what you see on your screen now is a screen group with the process, with the thread of control, which is the circular arrow. And we've added a letter in the middle of that circular arrow, which is Q. If you've registered a procedure to handle input and output, and you've created a thread of control, you need to register a data structure where messages for the window will be placed. And that is what is intended by the slide and by the Q in the center of the thread of control. The Q in the thread of control is what is used to serialize input, and this is very important. In systems like Presentation Manager, where mouse movements and keystrokes are used to control how a program operates, it's very important that the mouse motions and the keystrokes be processed in order. You would very much want, in a word processor, the write text to disk command to be executed before the exit command. It wouldn't do to exit before you wrote the information to the disk. And the Q is the means to ensure that serialization. On the screen now, you see a screen group again, and a process, and a thread of control with the queue. We've registered a window proc, and now, once we've registered the window, using its class and its WinProc, we can actually create the window, and that is what is meant by the little rectangle you see on the screen. So once all these things have been done, you can actually create a window. What you see on the screen now is a summary of all the little steps we've done through. And let's go through the steps one at a time. We launched a process into a screen group, which is the big rounded rectangle. The dashed rectangle is the process itself. Into that process, we started a thread of control, which is the circular arrow with the head. We registered a procedure to process input for a window. And we registered a queue to serialize the input to that procedure. The dashed arrow and serpentine line is meant to indicate the flow of information from the window to the window proc, so that you now click in the window screen real estate that's been multiplexed with a screen group, that then travels to the process and is sent to the procedure that's been registered to handle the input. So input is directed to a window, it's placed on the message queue of the process that created the window, and is subsequently dispatched to the window proc, responsible for processing the message. Every process can create 0, 1, 2, 3, n windows. So it's very important to know that you're not a process because you have a window. You are a process first, and then you check out as many windows as you need. For each window, there's a procedure to process input for that window. On the screen now is a diagram that is meant to show how information flows from each of several windows on the screen. We have the window screen group, and then we have 3 rectangles labeled 1, 2, and 3. Each of those rectangles is a window. Each of those windows has a line that goes from the window to the process and to the queue. And from the queue, that line goes to the window procedures labeled 1, 2, and 3. The idea is that all input from all your windows gets sent to the process. And from the process, it's dispatched to the appropriate window procedure for processing information for the screen real estate that you've multiplexed. On the screen now is a representation of multiple processes with multiple windows. Ultimately, there are several processes in the system, each of which may check out multiple windows, and all of them sharing the same screen group. That is graphically how we visualize information flow in the system. We take a screen group, we put a process into that screen group. That process has a thread of control. One registers a procedure to handle window input and creates a queue where that input can be placed. One then creates a window. Now that that chain has been created, it is possible to direct a keystroke to the window or a mouse movement in the window and have that information flow from the window to the process, and from the process's queue, have that go to the window procedure for which it's intended. And that is the flow and the overall schematic model of how input is handled in the system. So a presentation manager application is an application that's event-driven. Events are dispatched using messages. Messages are sent to threads or to processes and not to windows. They're sent first to a thread of execution and then to a window. Once delivered to a thread, the message is dispatched. Now, some of the events that are interesting are keyboard state changes, mouse state changes, timer state changes, things that happen to the window. The window has been changed its size, it's been moved, it's been dragged, or a change in state of the clipboard. All these events generate messages that go from the window, screen real estate, because that's where the event happened, to the process and to the window procedure for handling the events. A message in the presentation manager system has a definite structure, and it's always the same. Abstractly, the message parts consist of a target window, some message number, a menu selection, or some ID telling what needs to be done, and then some additional information and a mouse position. So messages always have the same format, and that's what you see on your screen now. This is a classic object-oriented approach to messaging, where you have a operator, which is the message, and each operator interprets its operands according to the message number. So, what is a presentation manager application given the pictures we've seen in the flow of information? A presentation manager application is a process that has a thread for processing events, and it pulls its thread looking for events and performing actions on those events. If the application creates a window, it registers the procedure to service the events in the window, and this is called the window procedure or the WinProc. The way that the flow of control of information through the system is done with messaging. These are the events that I've talked about. Events can be handled in two fundamentally different ways. Events can be asynchronous or events can be synchronous. So the presentation manager applications can elect to send messages to each other or to window procs in two ways. They can elect to send them asynchronously with win post message, or synchronously using win send message. Okay. Whether you consider something synchronous or asynchronous is whether you look at it from a system point of view or an application point of view. What's on the screen now is the terms asynchronous and synchronous refer to how the system views the sending of messages. Asynchronously is post message. In post messages, events are put on an event queue and you return immediately from post message. Consequently, from your perspective as a user of post message, the events are handled asynchronously because you put the event on a queue and then return immediately, and sometime later some other application will process the message, so it's asynchronous. Send message, on the other hand, is synchronous. Its semantics is that if you use send message, the receiver of the message is expected to process the message before you return. So in that sense, the send message is a synchronous passing of information. So presentation manager applications can send messages or get messages. In the presentation manager, it's very important that input is synchronized. For the example I gave earlier was, if you're typing very rapidly and you're working with a word processor, You may tell the word processor to write the changes you have made, and then you would tell the word processor to stop, or to stop the program, maybe with a W keystroke and then a Q keystroke for quit. It's imperative that those keystrokes be processed in order so that you don't quit before you write out the changes you've just made. So input synchronization in this system is achieved by allowing only one message queue thread to run at any one time. Other message queue threads continue to execute, but the one that is servicing the queue of input events, only one is running at any one time. And the reason is simple. In my example I just gave, it's fairly obvious. Okay, you'd want to process one keystroke before another so that you don't destroy a particular bit of information. The other way, and the more subtle distinction of why it's necessary, is that during processing the keystroke, it's possible for an application to change the flow of information to another window. Okay. That being the case, keystrokes must and mouse movements must be processed serially so that if one window changes the flow of control, things happen smoothly. What's on the screen now is my diagram for dealing with the message process diagram. Above the line on the screen, marked with a 0, are the threads of control that are processing message queues. Those threads of control that are processing message queues, only one thread is executing at any one time. That ensures that messages in the message queues are processed serially. Below the line are additional threads per process. Those threads are allowed to execute and are allowed to run, and those are labeled 1, 2, and 3 on the screen. Currently on the screen is the overall flow of control in the system. Events start with the mouse and the keyboard. They're put into a bucket called the hardware event queue. And from the hardware event queue, they're sent to the threads of control that will process them. From the process threads, they are directed to the window for which they're intended. So this on your screen now is the overall flow of information in the system in a diagrammatic form. To achieve all of the message processing, there's what we call the messaging API, or the messaging applications programming interface, those set of routines that are used to control messaging in the system. Message API, there's a way to create a message queue and to destroy it. That's when create message and when destroy message queue. There are procedures to send messages throughout the system. There's post message, send message. You can broadcast message to all windows with broadcast message. And you can decide to send messages that time out. If you've created a queue and you've been able to send messages, then you need to be able to get those messages off the queue, and there are a set of routines to do that. You can peek at the queue and see what's in it. You can get a message off the queue, and you can wait for messages to arrive on the queue. Once messages arrive on the queue, input messages arrive on the queue, they can be dispatched using when dispatch message. When dispatch message is the routine that takes the message and actually delivers it to the window for which it's intended. Sometimes during message processing, there's a need to know which state of processing you're in. These are the query functions for the model. You can say whether or not you're inside of a send message. You can find whether or not there's anything on the message queue with queue status. You can find out where a message is in the queue and the time at which that message arrived. Importantly, when get queue status is a convenient way to give up control of the processor. If there's nothing on the queue, when get queue status will give up control of the processor and yield control. A window consists of many parts. Each window part is a predefined window. So we have a window, and that window has various parts: a title bar, a size bar, system menu, scroll bars. Well, each of those is a predefined window that Windows defined, and they have a window proc. The behavior of the window proc and its response to input defines the window. The parts that we have defined, okay, are the frame, border, system menu, title bar, vertical scroll bar, horizontal scroll bar, etc. The important part here is that each of those parts of a window is a little window itself. It has a input proc, and it receives messages the same way as you perceive them to be received in the model I've explained. If you wish to change the behavior of a window, then you must intercept the messages to the window. So if you want to change the behavior of any of the little parts of a standard window, you need to intercept the messages and translate them. On the screen now is an example window, and you see the various parts. Upper right-hand corner, you see the minimize and maximize box. In the upper left-hand corner, you see the system box. You see a menu item below the system box, a title bar, and a caption. Simply remember that each of these little parts is in itself a window, and it responds to messages and it sends messages. For example, a scroll bar is a window. In response to mouse clicks, it may move the thumb or the elevator bar up or down in itself. And it sends a message back to its parent telling it to scroll. To summarize what we've seen, and take the big picture, the OS2 programming model is that of a virtualization of the system console. There can be several virtualizations running at the same time. One of those virtualizations is taken over by the presentation manager. Within that screen group, the screen real estate is multiplexed and partitioned into smaller parts using a window. Input to that window is sent to a process. From the process, it's sent to a procedure to process input for the window. A window itself is composed of many smaller windows. And we've seen how that model works. A message comes to a task, and from a task, it goes to a window procedure. If you wish to change the behavior of any of the parts of a window, you only have to know one model. And that's what we've explained.
For additional information on the topic we just covered, be sure to take a look at the written questions and answers that accompanied this videotape.